So thank you everybody has stuck around this far into the day. So Matt Scassero is actually the director for the University of Maryland Unmanned Aircraft Systems, or UAS as we call it, test site, a little bit away from campus. And he will be talking to us today about the UAS integration into the national airspace. With that, Matt, please take it away.
Great, thanks, Yancey. And I'm assuming everybody can see my slide and hear me okay. A thumbs up from me. There we go, thumbs up. All right. So I have really enjoyed today. I have learned so much. I got to meet some really awesome people in the poster session, the virtual poster session, but I am acutely aware that I am batting cleanup. And there's other social motivators. I try to figure out for cricket and middle order batsmen, something like that. Bottom line is it's a little after 1:30 in the morning, almost 2 o'clock in the morning in India right now. My best friend Rohan, who I met in the poster session, is probably like, come on, come on, come on. So I'm gonna get to it. What I'm talking about is how to get the research airborne. Everybody today pretty much talked about basic research and some applied research, a lot on the ground, some in the air, but talked about how to actually accomplish the tasks with technology, with algorithms, software, all the different tools that you all brilliantly know about and were able to talk about. But as Pratap showed and Mumu talked about some of the efforts there, we're kind of capped out for the most part at 400 feet and visual line of sight. So what I'm going to talk about is how do we go further? It's how do we integrate these into the national airspace? And while I do say national airspace, let me get my slide here. Okay, while I do say national airspace, it also applies to international airspace because the FAA works with the Canadian Airspace Authority, CA, the ICAO, the folks over in Europe and Asia. So everybody's working together to make sure that our standards are at least mutually agreeable. Some people may jump ahead in certain areas. Everybody wants to move ahead together. So these are the things I'm going to be talking about today. And again, I'm going to be talking about it from a US perspective, but you can put a larger ICAO, JARAS kind of focus on a lot of these things. I'm going to talk about the actual research that's necessary, that's required to get UAS into the national airspace. Talk specifically about what we at the test site are doing right now and in the future. And then a little bit about who's sponsoring this work and who really wants it to go forward to funding it, because it does matter and it plays into how we work with them. And I will put in that shameless plug at the end. Real quickly, who we are. The University of Maryland UAS test site, we're an operational flight research site. So we tend not to do basic research. And I tell people all the time, we're the BASF of UAS research. We don't do the research, we get the research airborne. So we work with researchers, industry, government, academia to get their stuff into the air and help affect the FAA regulation process, the FCC spectrum, all those things we need to get these things airborne and actually working for people. And that's who we work with. As I said, we're an operational flight research site. That's what we focus on. I'm a manned aviator as well as an unmanned aviator, 40 years of experience in aviation. That's what we bring to the table for this research. So we've been in business a little over 7 years now. We have our own airworthiness process based on the military's airworthiness process because we're an engineering school. We have to have an engineering approach to this. We do get expanded flight authorizations from the FAA, even though we're not an official FAA US test site. We do get, we have a great relationship with them. We get those extended authorizations. We have lots of projects, lots of vehicles. One of the best things, value propositions that we offer is that reach back. I work with Mumu, I work with Timur, I work with Jeffrey, I work with a bunch of folks who are doing amazing research, and we bring that to the table for our customers and our partners, folks that want to work with us. But pretty much everything we do is collaborative. Very rarely do we fly one project on one aircraft and call it done. We usually are using our vehicle, somebody else's software, another organization's sensors, whatever, to make sure that all that stuff gets benefit at the same time. So getting into what we're here to talk about. That upper right-hand corner there, you see a chart. That's an airspace chart for right around the Baltimore, Washington, Chesapeake Bay area. You can see it's very, very clobbered. Those circles are airports, the blue lines are restricted airspace and different classes of airspace. There's a lot going on. That's the problem we're up against. How do we fit drones into an already very, very busy, dense airspace environment? And even if you're in some place like North Dakota, someplace like that, it's still very busy and the risk is still there. So as far as the research that's required to actually go into that airspace to shoot for true integration into that airspace, you can see the items I've listed there. Remote ID, how do we know who's who in the zoo? Not just for control, but also for counter type of operations. How do we know when a nefarious player is getting involved in the airspace? The communications, command and control and payload. Right now, pretty much everything's RF radio line of sight. We know we're going to go beyond visual line of sight, and some people have done it. The military has been doing it for decades. So how do we do that without going to that expense that DoD systems go to when they go to satellites? We're looking at using LTE. We actually have one of the infrastructure owners here in the Chesapeake Bay, Crown Castle, owns all the cell tower infrastructure around here as part of our group. And then what are the different mesh network radio systems, things like that. One of the biggest ones, as a manned aviator, the thing they taught us from the very beginning was sense or see and avoid. You're always going to see and avoid, no matter what rule set you're operating under. You're going to use your Mark I motto eyeballs to see the other aircraft, avoid it. In an unmanned aircraft, you don't have that. The replacement for that is DAA, detect and avoid. That is one of the critical gotchas right now. The technologies kind of sort of exist. Radar, optics, LiDAR, they're all out there. None of them are set to a standard yet because the standards haven't been promulgated in their final form. So the technologies are here, the standards are here. We have to make those match so that we can actually use them in the airspace. Today in the airspace, we use air traffic control. It's positive, it's based on performance-based navigation, communications, navigation, surveillance equipment, exactly what Mumu was talking about. Everything's certified to operate a certain way, including the people. In the future with unmanned systems, it's going to have to be integrated in as part of ATC. Right now, they're looking at air traffic management, and I would say UAS traffic management. It's more segregated. It's kind of keeping drones off to the side as opposed to really integrating them. And then cybersecurity is a huge one that nobody was paying attention to until about 8 years ago or so, 10 years ago. And we always tell people, these things are nothing more than laptops with wings or rotors. You can hack a laptop, you can hack a drone. And that's actually the leading counter UAS methodology right now. And then reliability, system health reporting, prediction, that's the key to flying over people, which is actually one of the two limitations. Flying over people, flying beyond visual line of sight. And exactly what Mumu was just talking about, certification of systems, that has to go into that aspect as well. So those are the areas that we have to do and that we're getting involved in to actually go for that true integration. But there's also other, what I call very useful research. Autonomy, exactly what Mumu said, to get the max bang for the buck out of these, we really need to stretch the autonomy. Right now, what we do is pretty much level 2, and I'll use the ground vehicle levels. Level 2 is what we do now. Verging on a little bit of level 3. Some of the DoD vehicles, you're using level 3. Nobody is at real level 3, 4, and 5 with air vehicles. So it is something we're going to go after. And swarm for the economic efficiencies, as well as just the limits of how many aircraft we can put in the air with pilots, especially when the pilot workforce is actually diminishing right now. We're short pilots. So swarm is going to be an answer to a lot of things. And then aerodynamics propulsion, while that's not a requirement to get into the airspace, it can definitely be a benefit because now with unmanned systems, we can design the aircraft to the function. We don't have to worry about the people. We don't have to keep about keeping people breathing inside or comfortable, or don't bang them off the surface when you land. It's exactly based on the function of the aircraft. So aerodynamics propulsion really comes into it. And the bottom line for all this is the standards. We work with the ASTM F-38 committee, the RTCA Special Committee 228, as well as, again, ICAO and JARIS for the international standards. That is how this gets done. And all of industry and a lot of academia and government agencies are involved in writing those standards as we move forward. As far as the integration work that we are working on at the UAS test site, this is by far and away the biggest one, and it's really just getting kicked off. The Chesapeake UAS route network. And I'll show you a graphic here in just a second of it. But it's really to make this integrated on-demand airspace available for a range of partners and customers, not just for research, not just for demonstration, but commercial use, military use, public safety use, medical use, commercial use. So these are all the things, and all those things I just talked about, BV loss, flight over humans, remote ID comms, DA, all that stuff is going to be part of this project. We've already started working a little bit on this. Now is where we all start bringing it together. And it's not just going to be the US test site, it's going to be all of our partners. And our stakeholder group now is up over 150 organizations, from the FAA, NASA, and the FCC, all the way down to small mom and pops that want to use this airspace. So it'll be beyond the UTM kind of stuff that we're kind of segregated small efforts to true integration of the airspace. And again, on demand, it'll stress long-range communication. Like I said, we're working with Crown Castle for the LTE portions, Silvus radios for mesh network radios. It is going to be a long effort. We know that. Multi-year, multi-phase, but somebody's got to start. We're doing it now. And we're working in conjunction with the other states that have already started these efforts, such as New York, Virginia, Pennsylvania. This is a graphic showing notionally what that network will look like. We don't know exactly where the nodes are going to be, but we do know we want to incorporate the current points of interest around the Chesapeake Bay. ARL up at Aberdeen, Baltimore, they're flying drones in Baltimore with medical supplies today. Salisbury Airport, Crisfield, Wallops, where NASA flies out of with UAS. Down in the southern end, you got the Navy at Naval Air Station, Patuxent River. Our location here at St. Mary's Airport, and a little further west over to the Naval Surface Warfare Center, Dahlgren. And all these things you see on the left, that's how manned aircraft fly today. We have to make sure that we can fit into that kind of a structure, not create something special for drones, because that's not how it's going to work in the future with larger, more capable drones. So what else are we focusing on at the test site? In addition to that integration into the airspace project, specifically the Chesapeake U.S. Route Network, airworthiness. Again, what Mumu said, if you look really closely, you can see Mumu in that picture with the small rotor head there. That was an airworthiness evaluation we did on a vehicle up in Philadelphia a couple of years ago. So we do an airworthiness evaluation that leads to the integration certification. Propulsion and aerodynamics, that little vehicle there is out of a group in California, the state, not California, Maryland. And it doesn't even have a purpose yet. They just know it's something different that they think will have a purpose in the future. So we get involved with those folks. Like I said, we're working on autonomy. We're working on swarm, planning to work with Army Research Lab and Naval Air Warfare Center Aircraft Division and others, because that's how this stuff really becomes efficient. That bottom line there, though, that's the real value that we bring to the table, as opposed to maybe some of the lab research, things like that. We bring an aviation mindset and a concept of operations based on the way the FAA does business today and looks to do it in the future. And we want to help mold that and model that going forward. As cool as this project was, delivering the first human organ a couple of years ago in Baltimore to a waiting patient, this was not integration. This was a segregated operation. It kept everybody else away. The streets were actually closed beneath us, so that in case something happened, I was following it in a police car with sirens wailing. It was a great project. It was a good demonstration of what can happen someday. A company was actually formed out of it to go do this, and they're flying today in Minnesota, Nevada, and here in Maryland. But that is not what integration looks like, but it's a great lead into what the future will be. So who's sponsoring these integration efforts? The FAA is leading the way because that's their airspace. The federal preemption concept is still valid. And from my perspective, at least, and many others, it needs to remain valid. There's a reason that we have the busiest as well as the safest and most efficient airspace in the world. And it's because of the safety case approach that the FAA uses. Their notice of proposed rulemaking process, the NPRM process, is very long. It takes 2 years to go from draft to final. And that's assuming you take care of all the comments. Most rules, they get maybe 100 or less comments. The last NPRM rule that the FAA came out with about drones had over 10,000 comments. So the comment process takes longer. The FAA is a full partner in our project, the Chesapeake U.S. Route Network. They've given us lots of guidance already. We're looking to stay in lockstep with them. NASA, I have some comments here about NASA. Please don't take this the wrong way. I got my NASA socks on today. I love NASA. For UAS purposes, they have been directed to do portions of the research that are going to be necessary to go to integration. They have not taken on the big problem of the airspace integration for UAS. So they've done great work on UTM, but that was a very segregated, and it was based on some assumptions. The assumptions were low altitude and small UAS only. So that's not where our future is. We know that, so we need to aim higher. Sorry. But NASA's been a great partner. Industry. The FAA is very clear. They exist for the commerce of the airspace. So the industry folks are part of the solution. The solution folks that actually do the computer systems to control everything are on board. They're making things happen. They got great capabilities. The user industry is kind of interesting. The bigs, the Amazons, the people like that, they want to buy it. They want to buy it, own it, and run it themselves. We, from the manned aviation, the FAA, the aviation world, don't really want to see that happen. So there's a little bit of a tension there. And then the states are very big, the ones that want to see it happen. Maryland is now part of that. I wish I had New York's money. They put $250 million against drones for a 5-year period out of their Wall Street bailout money. Anyway, that's not us. And my timer just went off, so I'm finishing up. How to work with us. Shameless plug. Get involved in our Chesapeake UAS project. Get involved with me. You can see my contact information as well as our website and our Twitter account there. Get in touch with us. Let us know what you're interested in. There is going to be a lot of basic research that gets folded into this project. When you talk about sensors, things like that, Johns Hopkins is doing ACAS-X with us. You also can propose ideas to work with us if you want to work on STTRs, BAs, cooperative agreements, whatever. Figure out what the idea is, get to the specifics of the work. If we offer value to you, great. And as Dean Rob Reiber mentioned earlier, the new Matrix Lab at the USMSM opens this fall. You can see under construction there, that's the indoor RF shielded open air lab. So it's huge. We also have a smaller anechoic chambers, all kinds of great facilities in there, as well as a fluid dynamics tank. And it opens in about 4 months. And with that, that's my get off the stage. So I really appreciate everybody's time. The group of you that have hung on to the bitter end, I appreciate it. I'm open for any questions and whatever Yancey and Pratap want to throw at me.
Thank you so much, Matt. That was a great talk. We do have one question on the Q&A feature, and so I'll read it for you. So it says, do you think a new paradigm of guidelines will need to be developed in terms of safety as aerial platforms become increasingly intelligent?
So I'll give you kind of a two-part answer to that. My gut feel from my experience in the unmanned community, as well as my experience in the manned aviation community, I don't think you'll see a new paradigm of guidelines. They'll have to make modifications, exactly what Mumu said. How do you certify an autonomous system? So we'll have to make changes to the how we do it. But the basic paradigms, the basic guidelines, I don't think will change, and I don't think they should change because it works the way it's set up. We will obviously have to make allowances for things like autonomous systems, things that unmanned systems flat out can't do, at least today. So the FAA has some great ideas about next gen, which is kind of air traffic control in the next generation, and even beyond that. When we get into things like quantum computing and the processing power that that provides, swarm, autonomy, those companies coming together all at once, I see an ATC of the future, air traffic control system of the future, that is vastly different from the way it is today, but it will still be based on one main thing, the safety case analysis. Why is the way you want to do it safer than the way you do it today?
Great, thank you so much. And I want to take the time